Okay, you may have heard of the golden ratio Fibonacci sequence. You may have seen the golden ratio expressed as 1.61803, or maybe just 1.618. I'm going to show you how that number is calculated, what the golden ratio is, and how it relates to the Fibonacci sequence. So really, everything starts from nothing, 0. And we're going to think of these as having a mirror between them, these numbers. So 0 is going to look into the void, and somehow it's going to see creation, 1. Okay, so when they look through the mirror, they're going to combine with each other, these numbers. So as 0 looks through the mirror, it sees 1. If they combine together, 0 plus 1 equals 1. Now every number is going to look through the mirror, I guess see its past or future self. You're going to combine the two numbers, so 1 combined with 1 is 2. Now 2 is going to look through the mirror to 1, and they're going to combine to make 3. And they're just going to keep looking through that mirror at each other. And you just have to add the two numbers together. That's all you have to do. So 5 plus 3 is 8. I'm going to keep going. 5 plus 8 is 13. 8 plus 13 is 21. 21 plus 13 is 34. 21 plus 34 is 55. I'm going to continue down here. So we had 34 and 55, right? Let's just have 55 here for continuity. 34 and 55 is 89. 55 and 89 is 144. Everybody's just looking through the mirror at their past self and combining into something new. 144 plus 89 is 233. We'll stop there. Okay, so this is the Fibonacci sequence we've just calculated. Just by thinking of numbers mirroring themselves, really. You can think of them as the number and the previous number adding together. I like to think about it as a mirror. And here's why. To calculate the golden ratio, all you have to do is pick two of these numbers and divide the larger number by the smaller number. That is the golden ratio, is the ratio of the numbers of the Fibonacci sequence. So this is actually my favorite thing that happens here, because on the first sequence, if we divide 1 by 0, what do you get? Well, if you know calculus, you know that you get infinity, which is incredibly interesting, right? Because from nothing became something, and the ratio of that is infinite, the Big Bang, right? Whatever you want to think about it as. 1 divided by 1 is 1. 2 divided by 1, 2. 3 divided by 2, 1.5. 5 divided by 3. I'm going to start using the calculator here just so it's very evident. 5 divided by 3, 1.6 repeating. Okay. This is 1.6 repeating. I'm just going to type all these in real quick and then we'll write them down. So 8 divided by 5, right? 1.6. not repeating, just 1.60000. So now we're getting closer to this golden ratio number that I've written here. Okay, let's do the next one. 13 divided by 8, 1.625. Closer still. 21 divided by 13, 1.61538. Closer still. So if you continue doing this, 55 divided by 33, or 55 divided by 34, excuse me, 89 divided by 55. Look, we've arrived. 1.61818. It's not 03, but let's do the last digit. 233 divided by 144. 1.61805. I could keep drawing this out, actually. Let's just do it so that we can arrive on the number that I've had a green box around there. So 233 and 144 is 377. 377 mirrored with 233 is 610. 610 mirrored with 377 combined become 987. 1597. 2584. Stop there. So let me write all these with some digits. 1.6000. We're going to do 4 digits after the decimal. This is going to be 1.6250, 1.6154, 1.6190, 1.6176, 144 and 89 ended up being 1.6180. So let's go up here to 1597 divided by 987. This ended up being 1.618033, and this was 1.618034. So you can see here that we have 1.61803. That's the golden ratio. I'd encourage you to do this exercise yourself so that it makes sense. Whoops, this thing was blocking it. Sorry about that.